Okay, recording started. Good evening, everybody. So, before I jump in, anybody has any questions? So we'll always start with questions, right? So let's start.
Yes, I have one question.
Yes, Madhavi.
In the set, can I pass string and integer both?
It's a good point. So, Madhavi is asking a question. Can I pass both string and integer both into a set, or probably for any collections, right? So let's
Yes.
say, before JDK 5, okay, until JDK 4, actually in JDK 5, they introduced this new concept called generics. This one, set of students, right? So if you look at actually go look at this, my previous batch videos, probably either in the current batch. So somewhere here you will see it, okay? In this video you should be able to see it, or even in the one batch before also you should see it here, okay? So the point is, before JDK 5, we don't have this concept of generics. We don't have this concept of set of student. We only have like this. We declare like this, set set names equal to, okay, new hash set, like that. Even this one, let's take out. So now here, names dot add, you can add a string, okay, and you can add an integer, and you can add a student object here. Oops. You can add a student object here, etc. So you can add anything to this particular set. So you don't have to declare this as a set of student. At compile time, you don't have to say it. So you can add a string, you can add an integer, you can add a student, you can add a laptop, everything to it. Okay. So you added a basket. It's like a kitchen sink. You can add anything. Now you are sending this set. So what does he do with this kind of set? What does the receiver do with this kind of set? He has to iterate and read through it, right? At this time, when he reads it, how he has to know, when you iterate through it, it gives you a generic java.lang object. Now, you need to typecast to the real or the actual object inside that. So you need to typecast to a string, or you need to typecast to an int, you need to typecast it to a student, right? So not lot of times, every time here, your compiler is not really helping you. You wanted to add only the strings, let's say, to this set. But you are able to add an integer here, and you are able to add a student object also. Your compiler is not helping you because you made a mistake, and your compiler is not slapping you at the compile time itself and telling you that, sorry, you can't do it. Because this kind of set is useless. What does the receiver do? The receiver does not do anything about it, because he has to, if it is the first one, then he has to typecast to string. If it's a second one, he has to typecast to integer. If it's a third one, he has to typecast to student. So it's a generic kitchen sink bag. Okay? That is why they introduced this concept called generics. So here at the compile time itself, set of students equal to new hash set. So what you're doing here is that at the compile time itself, you are telling compiler your intentions very clearly. Hey, this bag is going to contain all the student objects. If I try to add anything else to the bag, okay, let me see. I'll try to add Venkat string. If I try to add string to this bag, see, compiler is going to slap us saying that the method add of student in the type is not applicable for the argument string. You cannot add string to this bag of students. So it is not allowed. In JDK 4, before 5, you can do it, but that's very, why do you, I mean, you can create a bag to add multiple things, but how do you differentiate it? How do you know? What do you do with that bag? When you iterate through it, you really have to find out the type, right? So that is why we never have to do anything like that. We always use this generics. Did I answer your question?
Yeah, I got it now. Thank you.
No problem, no problem. In fact, if you watch my previous batch once, here I talked about how do we do that using, pre-JDK 5, how we used to do the things. Okay, and we have to typecast, etc. They have a lot of, it has a lot of disadvantages. That is why in JDK 5 they introduced this generics concept. Okay, now let's jump into it. So in the last class, we talked about linked list. That's one of the implementations of list interface. And we also talked about set interface. Set does not accept duplicates and set does not maintain the order. And then we looked at a couple of implementations. One is hash set, the simplest, the quickest implementation of set. And under the hood, it uses the hash-based functions, right? It uses hash code. And hash code and equals, that is why you must always override both hash code and equals whenever you put your objects into the collection objects, whenever you add your objects into the collections. So that's one of the most popular interview questions. Hey, what are the two methods that you typically override when you deal with the collections? Equals and hash code. Why? I think we talked about it. So now let's talk about one more implementation of set today called tree set. In fact, before I talk about tree set, I wanted to talk about one concept, whether you understand this or not. So we took this example yesterday, right? Set of student. So set of students equal to new hash set. Go ahead, Jyoti, you have a question? Ask.
Yes, Venkat. So, suppose we are not overriding the equals or hash code methods, and when we try to insert the duplicates for the hash set, we don't get the compile time or runtime error, correct? The only thing that it would do is for the add method.
Precisely.
It would just return it as false type.
Exactly. Exactly. Precisely. You do not get any compile time errors. You do not get any runtime errors. Okay. It's just that when you try to add the second time, it will not add it.
Okay, and it will write the add method return type as false.
You got it. Add method has a return type that is a Boolean type. It gives you true if it has successfully been able to add it to the basket. Otherwise, it will return false, meaning that, hey, it's already there. You're trying to add a duplicate and set does not take duplicate, so I'll throw you false.
Okay, and also one more thing, Venkat. So when we have a lot of, if we want to have a lot of search capability, hash set is the best. So how can you just explain a little bit how search is kind of faster if we just take hash set?
Actually,
maybe if you have, maybe you can cover it later also.
yeah. Well, let's talk about. I wanted to talk about few things today, so let me cover them first, and then we'll come to that.
Sure. Thanks.
So, thing that I wanted to talk about here is we looked at the set of students equal to new hash set, and then we overrode both equals and hash code. Everything is good. But one thing that the very early on, the first example that we have looked at is we added all the names here: Yuri, Venkat, Oma, Shekhar, and Yuvi. Let's run this one more time. What did you observe here? One, it does not maintain the order. And number two, Yuri is gone second time. Second time Yuri hasn't been added. So now, string is also an object like student, right? Your string object is also like a student. You have student object, similarly you have string object. But when you added strings, how did it find out that Yuri is a duplicate of the first one? Are you getting my point? Here, this is an object, right? So an object has been created under the hood and then added to the basket. And here, when you try to do it with Yuri second time, when you try to add Yuri again to the basket, how your hash set is figuring out that, hey, Yuri already exists, I should not add. What exactly is happening under the hood? Well, what exactly is happening is, it doesn't know that in the case of strings, I have to look at the string of characters Y, U, R, I. It doesn't know that. Your hash set doesn't know all of these details. Hash set only knows that first it calls the hash code method. If hash code is exactly same, then when it is trying to keep this object in that particular index, it will call the equals method if there is something else, right? So hash set always calls the hash code and equals method. It doesn't know that if it is string, I have to do it differently. It does not know that. So what exactly is happening here is, in the case of java.lang.string, is that these are two different objects. This Yuri and this Yuri, these are two different objects. And then these two different objects should produce this different hash codes. In that case, they both should be sitting somewhere under the hood. There is an array here. First Yuri should be sitting here, and then the last Yuri should be sitting here. Right? They both should have the different hash code, right? If they were having different hash codes, then Yuri, this Yuri also, your hash set would have treated as differently, and then it wouldn't have thought that this is a duplicate of this one. what exactly happened is, like our student object, okay, if you look at java.lang.string, they overrode hash code and equals methods. They overrode hash code, okay? So the way they overrode the hash code is, they will look at each character inside Y, U, R, I. Each character will have a hash code, and they'll do hash code of Y, hash code of U, hash code of Y plus hash code of U plus hash code of R plus hash code of I. So that is how they overrode the hash code method in java.lang.string. That is why you will see the same hash code here. You will see the same hash code. Very good. That is why these two will have a conflict here. They both, since they both have the same hash code, they both result in the same index under the hood under the hood array. Next one is, it will find out if the two objects are exactly same. For that, it will call the equals method. When it calls the equals method, I told you yesterday that by default your java.lang.object will give you equal to under your equals method. But there are two different objects in heap, okay? This is URI, the first URI, and this is the last URI. There are two different objects and two different object references, okay? Y1 and Y2. Y1 is pointing to this guy, Y2 is pointing to this guy. So if this is exactly is happening, if equal to is what you are getting java.lang from java.lang.object, then how is it actually comparing these individual characters and then finding out that this URI is exactly same as this one? So in the case of string, the characters need to be compared. If the characters are exactly same, then those two objects are equal. How does JVM know about it, or how does your hash set know about it? Well, your hash set does not know about it. Hash set only blindly calls your hash code, and if hash code is same, then it will call the equals method to see if they're really equal. But the magic is here in java.lang.string. They overrode equals also in such a way that, hey, this is what I'm getting from java.lang.object, right? So no more object references. No, they are never same. But now you go to character by character, and look at both the strings Y, U, R, I in one case, and in other case also Y, U, R, I. It looks at character by character. If both of them, in both the strings, if the characters are exactly same, it returns true. That equals method. That is how they overrode. Agree? The magic happened here in java.lang.string. They overrode both equals and hash code. That is why it works here. That is why it works. And then in the case of student, the reason it did not work is because we did not override equals and hash code at the time. Now we overrode happily equals and hash code. Everything works fine. Yep, you are right, Aruna. So equals method has been overridden in java.lang.string. That is my point. Now let's look at the next one. Now let's look at the next implementation of set called tree set. Let's look at the next implementation called tree set. So we looked at hash set, we looked at linked hash set. In the case of linked hash set, it maintains the order. But now let's look at the tree set. What tree set says is that, hey, as the objects are added to the basket, this basket is nothing but the tree set. As you add these objects to the basket, I will sort them. I will sort them. I will sort all of these objects however you want it. You define how you want your objects to be sorted. Maybe all the student objects, you want all the student objects to be sorted based on their student ID. Okay, you want all the student objects to be sorted based on their student ID. Or you want your student objects to be sorted by their name. Okay? Or you want all the student objects to be sorted based on their zip code. However, you provide your, how you want your sorting, how you want the sorting to be done. And then as you add them to the tree set will automatically sort them. It will call, like exactly in the case of hash set or any set functionality, right? Any set implementation, it will call equals and hash code. Similarly, in tree set, it will call that particular method to find out whether I need to put it before or after that particular object. So all the strings are actually sorted naturally. All the strings are sorted naturally, meaning according to the lexical order. The lexical order meaning dictionary order. So alphabetical. That's what I meant. Alphabetical order. A, B, C, D, E. Okay, let's look at it. I'll show you a tree set demo. Okay, now set of string students equal to new tree set, java.util.tree set. Now let's add students.add. I'll start from the bottom, Yuri, and I'll show you how it flips, or I'll add people randomly. Let's do it. Yuri, and then antenna, and then somewhere in between Shailaja. And someone from above, let's say Aruna, like that. Okay, so I'm adding like this, right? So obviously first Yuri gets added into the basket. So first one here, so Yuri gets added here. And then when you add antenna, then it will figure out, hey, I have to do based on natural ordering. Again, here also tree set does not have any logic. It will call a method. There is a method called compare to in a specific implementation. I'll talk about it in a minute. But it will call that method to see where antenna goes when compared to Yuri. So obviously that says that, hey, antenna will go up. Okay? So it will keep antenna here. And now when Shailaja comes into picture, now it will compare with every object. It goes between antenna and Yuri. So Shailaja goes here. And then again, last one comes, Aruna comes into picture. So she has to come after AN, after AR. So after, it will compare again with each one, and then it will do like this. So antenna, Aruna, Shailaja, Yuri. Let's look at it. That's how it stores everything. Okay. Okay. Let's look at it and see. See, Antenna, Aruna, Sailaja, Yuri. So it maintained that lexical order. But tree set does not do any magic here. Tree set does not have any logic to actually order them in a lexical order. What it says that you define your order. Every object can define their order and I will honor it. That's all it says. So every object, string, every object that you want to be sorted, what you need to do is you need to implement an interface. In this case, we want to do it what happens in the case of student, right? So we want all the objects to be sorted. Now, every object that you want to be sorted must implement an interface called comparable. Implements java dot comparable interface, java dot lang, and then we will compare. This is of comparable of student. So we will compare every student with another student object, right? And now this comparable interface has a method called compare to. In that compare to method, we have to write how we want our objects to be sorted. Agree? And now control 1, add unimplemented methods. Now let's go and look at it. See this one? There is a method called compare to. Okay. Now you can say student, you can say that because we already have this. So by the way, don't get confused with that. There is no that super word. It's a variable name. That's all. You can use anything here. And now you are returning int here. Now let's talk about this int. What is this int? Well, it can return 3 values. One, you can return positive, you can return negative, or you can return 0. So in this case, when Antenna and Aruna gets compared, okay, if this object is should go before it, then sorry, if this object should go after the past one, then you return plus. If it should go before, then you return minus. If the objects have exactly same, then you return 0. Meaning, if the two objects, if you get exactly Aruna and Aruna, then we get 0, right? Then plus is after. Minus is anything negative is before. So let's talk about it. Let's look at it with an example here, right? So what do we want to do now? We want to compare. We want this dot ID. Okay. We want this one to be compared. If this one is, so we have, oh, by the way, what is our sorting mechanism? Let's sort all the students by their ID. Okay. Now let's compare. If this dot ID is greater than that dot get ID, I'm comparing both IDs. Okay. Then let's return a positive number. Let's say 1. Else, if this dot ID is exactly, or let's say equal, less than that dot get ID, in this case, let's return -1. else then let's say return 0. Meaning if both the IDs have exactly same number, then it doesn't matter where you put it, right? Right? Both the objects are same. So now using this one, it will sort all of them. You get it? So whether I should put before the existing object or after the existing object, or it doesn't matter. Now, by the way, if you're wondering what exactly happened with the strings, string class already implements comparable interface, and it provided its own implementation. It provided its own implementation to the compare to method. That is why it is sorting all of these objects in a lexical order. Okay, but it doesn't do any magic. So let's look at our tree set. Tree set demo 2. Okay. So let me get all of these objects. I can actually copy this code as is. Now, student, let me give student ID 5. Let me give student ID 1. Let me give student ID 4. Let me give student ID 3. Okay. And then I will order this way. I'm adding student with the ID 5 first, and then adding with the student ID 1 next, and then adding the student ID 4, and then adding student ID 3. But I'll not use hash set, I will use tree set. Good. Now I'm adding, I don't need hash code. Yep, I added all of them, and now let's print all the students in that order. Let's look at it, how it prints. See this one? It actually put this in this order 1, 3, 4, 5. Because it will go ahead and add the first student. This is exactly what happens under the hood. If you want to look at it, let's go through this example. This is a basket. Right? Now you added first student with the 5. Okay, this guy has been added. Oops. Let's say the 5 guy has been added, right? Now 1 guy has been added now, right? Now it will call this one object dot compare to. Where should I put this one? Okay, so then it will call the compare to method of your student and see that, hey, where are you right now? So the new one is the new one has to be below, because that is less than this one. So let's go here, and then it will say the one with this guy has to go here, and then it will find out, it will call 4. Okay, then now this object 4, when I call this one, I will call the compare to with 1, and then it will say that, hey, you are not before me, you are after me. I'll return a positive number now. Now I will call with 5, and it will say that, hey, you have to do before me. Okay, then I'll figure out that 4 will go here. And now when it comes to 3, it will start again. When I call with 1, it will say that, hey, you are after me. Okay, good. Then I'll call 4. I'll say that, no, you are before me. Okay, I'll squeeze 3 here. So that's how I'll get 1, 3, 4, 5. Okay, and then if you want to do, let's say you want to sort all of these people by their name, right? What you can do is, in that case, if you want to sort all of these people by their name, all you have to do is return this dot name dot compare to that dot get name. So you compare existing name, this object's name, you compare this object's name to the new one that has been given to me, and then there is a compare to method. As I told you, java.lang.string is already implementing comparable interface. It is already providing the implementation for the compare to method, so you can safely call that one. Okay, and then by the way, in java.lang.string, it already provided the implementation for compare to compare both the strings in lexical order, meaning according to the dictionary. Okay, alphabetical order. So now you compare it. Now you will see. Now what will happen now? Their name Venkat and Venkat has to come first, and then Uma has to come next, and then Yuri has to go next, but it's the same order, right? So what we'll do is we'll change this guy. Let's give this one Yuri, but this one Aruna, and then someone with C, someone with Jyoti in between. Okay, and then Kal. Let's add. Now look at it. The same Aruna, Jyoti, Kal, Yuri. They are not ordered by their numbers anymore. We don't care about their IDs. See, it's not sorted by their IDs. It's rather sorted by their names. This is how we can provide our own implementation. Okay? This is the lexical order. So you can provide your own implementation. Make sense, everybody? That is tree set. Any questions? No questions?
Venkat, I have a question.
Absolutely.
I know that you already explained in yesterday's class too.
No problem,
about
Alex.
this and that. Yeah.
Yep.
So I'm clear about this this name.
Okay.
This is to the that one. You said you can give any variable name, but that
This is
one
just a, go ahead.
refers to which
Object.
can you please explain about that get name?
Absolutely. So here, okay, when I say student S equal to new student, okay, let's look at it. When I say S1 equal to new student, right? Okay, understand this carefully. Student S1 equal to new student. Okay, so we have an object called S1. Now, student S2 equal to new student. Okay, now let's do this one. S1 dot, S1 has this method, right? S1 has this method called compare to. S1 compare to, I'm passing S2. Now look at this one with this code now. Uma, side by side, let's look at it.
Yeah.
Whatever I wrote here, let's look at both of them side by side here. The actual code versus what I wrote here. So this is the first object, right? You are calling compare to on the first object, right? S1. So you are calling the compare to here. whatever the object that you are calling this method on, this is this one. So in this case, S1, you are calling on S1. So this means your S1. Agree? Now you are giving this, you are expecting an object here, right? You are giving this S2 here. Look at it. You are passing S2 as an argument. That is what this one is. So you're passing this S2 you're passing, right? And that S2 is here. So this is actually this in this case, and now this one, this argument here, okay, English, this argument here is, I can call anything, right? Other, let's say other, okay, or obj, or you can call student. It doesn't matter what it is. Whatever the object that you are passing, I'm comparing my name. You are calling this compare to method on me. On me means what? On this object. You are calling compare to on me. I'm inside S1 now, Uma. I'm inside S1. You called my compare to now. When I call this compare to, so what happens is you passed me something, right? You passed me S2. So here in this case, student is S2. So now my name, I'm comparing to the object that you gave it to me. Here S2, S2.name. So I'm comparing this S1.name compared to S2.name. Does that make sense?
Yeah, got it.
Sure?
Yeah, sure. Yeah, thanks. I was wondering from where this the second one is compared to. So,
Did you get it now? Because
yeah.
this method is called on S1, and you are passing an object here, right? This is exactly that S2, I'm passing it. Now that is what here is referred to as whatever you pass it. Right? Agree? The reason, I'll give you the
But
reason.
I think that makes a lot of sense here then.
I'll give you the reason why a lot of people like to call this as that. The reason is you are inside a student object and you are comparing this guy with another student object. So both happen to be the same student objects. If it is something else, if it is animal, clearly I can say animal. Right? So there are two student objects. The one you are already in is being compared to with an external object that you have been passed to. See this one? You are calling S1 dot compare to. So you're calling compare to method on S1 object and you're passing S2 object as a parameter. That parameter is this guy here. Make sense? I hope that's better now.
Yeah. I'm clear now. But I think that makes a lot of sense than student here.
Exactly.
Right.
That is, did you understand now? Because we are comparing the same, exact same objects, that's why a lot of people call that as that. Meaning a different object that you gave it to me. This means the object that I am in already. I'm in this object and now you gave me a different object of the same type. That is why they call it that. See, it doesn't really matter whether you call that a student or Uma. It doesn't really matter, Uma. But as long as we understand the concept, same.
Yeah.
Right?
Yeah. Thanks, Ankit. Yeah.
No problem, anytime. So that's about it. Any other questions? That's a very good question. To be honest, I was getting confused until very recently, just few years back. So okay. So a lot of people get confused, even people with lot of experience. So, okay, feel proud. Now let's talk about a different breed of collections now. So once we are done with set and list and set, these are the most popular ones. There are a couple more. There are a couple more data structures. One of them is called queue data structure. In the queue, first in, first out, meaning like you're going to a movie and you are standing in queue, right? I think this is the same example that everybody takes it, right? In a ticket counter, you are standing like this, okay? So this is a queue data structure, meaning when you add an element, you always add to the end of it. Now, there are 6 people already here, this guy being the first, second, third, fourth, fifth, sixth. Now, to a queue, if you add an element, it will be added to the 7th. Okay? Now, you ask me to get it. When you ask me to get it, you will actually get the first one because first in, first out, because this guy is in the queue for a long time. So this guy has to get the ticket first. So you will always get the first guy when you read it. But when you add it, you'll always will be adding to the end of the queue because the queue works like a first in, first out. And there is a different data structure called stack. The stack works like your stack of cards, your deck of cards, right? So your deck of playing cards like this. So the last in, first out. Stack is last in, first out. Here, first in, first out. They call it FIFO and LIFO. Stack means when you add to a deck of cards, obviously you will be adding here, right? The last guy is on the top. When you ask it to give a card, then obviously it gives you the latest card because that is on the top of the deck. Okay, so there are 2 more data structures. These are standard every programming language like C++, any other, C#. Okay, so the queue and also that's how they work, queue and stack. Java supports. There is an interface called queue here. Actually, in fact, linked list implements queue interface also. Play with it. And then there is a class called stack. You play with it too. There is a push and pop button methods. When you push, you are adding a card to the deck on the top. When you pop, you're taking out, you're removing it. But when you remove it, obviously, you take the latest one, the last in, first out. Okay? Now, let's talk about another breed of data structures, another breed of collections. In the collections framework, we talked about, this is the hierarchy. This is the hierarchy. Collection, list, and set. And then you have several set implementations, has set, linked has set, etc. In list, you have error list, linked list, etc. There is a different collection interface as part of the collections framework called map. Okay? This map data structure is used when you need to place objects with key and value pair. Key and value pair, meaning the best example that I can think of, and I always use it, is the telephone number, telephone directory, right? In the telephone directory, you can add name and their phone number, name and their phone number. This is the key and this is a value here. This is a key and this is a value here. and it's actually stored in a bag or data structure called a map here. Okay, and then if you give the key here, map is exactly like your book, like how you are writing in a book, your key and value, key and value, key and value. You give me the key, I'll give you the value. You ask me for all the keys, I will give you all the keys. Or you ask me all the entries inside, each one is an entry, right? Name and value pair is an entry. You ask me for all the entries inside a map, I will give you. Now, you give me key and value pair, I will add to the telephone directory. I mean, I'm saying map. Okay, it doesn't have to be a telephone directory, it can be anything. But when you have a situation where you need to insert or you need to put it into a bag where every object is stored with a key. Okay, that key 9 out of 10 times it's going to be a string, but it doesn't have to be a string. It can be, the key itself can be an object too. But I'll take the simplistic scenario, which is string. That is what we use it 90% of the times. But the key can be an object too. Okay? That's it. That is nothing but a map data structure. And there is an implementation of map. The simplest implementation of map is called hash map. Again, it is based on your hash functions. That is why it is called hash map. Your hash code will be used. Your hash code will be used. If you really look at, again, if I open up the actual map, the hash map implementation that is provided by JDK, your Java, okay, under the hood, it is actually an array data structure. Again, under the hood, it is an array data structure. But now, let me provide, let me say the first one is Anup. Okay, I'll say Anup is the key. I'm maintaining a telephone directory here, and our phone number is 1234. 1234. Okay, and then antenna, I'm taking in the lexical order. His phone number is 4321. I'm taking their phone numbers. Okay, now when you add Anup as a key and 1234 is a value, I'm telling you this is an array data structure. So first what I'll do is I will take this key. Anup is the key, right? Now I will get the hash code for Anup string. I will get the hash code of this object. I will get the hash code of that object. What is this object? There is a string object under the hood, right? So I will call the hash code of that particular string object, and now I will get it. So based on the hash code, I will perform that complex algorithm, multiply by the maximum number, the array size, etc., and find out, hey, where should I put this object? Okay, I will put this guy in, let's say index 3 here, right? Okay, so here I'll keep this guy here, 1 2 3 4. Okay, and then here the key is Anup here, right? Now let's say there is another object called, let's say I've used another key called Poona, Poona. These two, Anup and Poona, they both have the exact same string characters. If you have the exact same string characters, they both will have the exact same hash code also. Your cat and tack will have the exact same hash code. So since they both have exact same hash code, they both result in the same location, which is number 0, 1, 2, 3. Let's say 3. Now, your Poona, should I replace there is one already an entry here called Anup1234. Should I replace here? Then it will call the equals method on the keys. Hey, is it exactly same as Anup? Oh, no, it is not. Because your string of characters are reversed, it's not exactly same. Then I will put both Pune and these two entries, Anup and Pune, both of them in the same location. So it's exactly based on your hash, like how hash set works. It exactly works like that. So it behind the scenes calls the hash code. That is why I'm saying that your keys don't have to be strings, any object that implements hash code. Okay? But you provide good hash code. You override hash code and provide a good implementation so that all the objects, they are actually spreaded nicely across that array data structure. So, but 9 out of 10 times we use a string as a key, and anything else can be value. Now let's look at an example here. I'll create a new package here. By the way, I'm immediately checking in the code. Right after the class, I'm checking in the code. So you can go home and get all of these examples. You just go home and check out. Collections.map. Okay. Let's say hash map demo 1. Fantastic. And then I'll say map of key and value. I'll say you have to say at the compile time itself what object are you using as a key. This is the first one is what object are you using as the key, and then what object are you using as the value. I'm saying string and string because my keys are strings, my values are also strings. Okay? I'll say phone book equal to new hash map java.util.hashmap. Now there are two different methods that you typically use. This is the empty phone book. Okay, now we need to add entries to the phone book, right? Each entry will be added into the phone book using this method called put. Okay, map.put, you provide your key and you provide your value. So the first one I'll say is Anup, and then value is 1 2 3 4 5 6 7 8 9 0. That is the phone number. Okay, see here, this is the key and this is the value. But I'm saying your key does not have to be a string. Here we declared as a string, but your key 9 out of 10 times will be string, but it doesn't have to be though. Now your object can be anything. In fact, object will not be string typically. Okay. In fact, yeah, I'll tell you. I'll look at let's look at more complicated example also. But this is a very, very, very simple example with key as a string and value as a string. So Anup, and then I'll take somebody, Lena. I'm just taking randomly this time. Okay. And now let's take these latecomers. Venkat Krishna, he just joined, and then Manikanta, I believe, or Rohit. One of them joined just now. So let me use them like that. Okay. Somebody has joined. I think Ravi has joined later. Yeah. So let's use Ravi. 1 2 3 8 7 9 1 2 3 0. Okay, this is the phone book. Now let's look at it. The first scenario here, scenario 1. If you know key, you can get the value, right? You can get the value. Do you know the key? Now you ask your phone book, hey phone book, can you give me Ravi's phone number? Just say phone book dot get. There is a method called get, and ask this guy, and you give your key here. What is your key? This is key. This is the key, and this is the value. Okay. Now I'll give the key as Ravi, and I'll get the object. Now this returns string because you defined your value as a string. Right? Now string Ravi's number is whatever that one is, and then let's print it what we got it. Ravi's number equal to, okay, see, it gave you 123,879,1230. That is Ravi's number, and then you can get somebody else's number. It's using the get method. You can use the get method. Let's say Lena's number. So you need the key. I got the key, and then Lena number. I'll say okay. Sweet. You got it. And this is the scenario 1. Now, scenario 2. Let's say you don't know the keys. Somehow you got that map, you got the phone book, and you want to look at every single entry within that. Every single entry within that. You want to get every single entry. Okay? One way to do it is, first let's get all the keys, all the names in the phone book, and then once I get it, I can use this method, right? I can use this method, right? So first let's get it. Let's say scenario 2, right? Scenario 2. Get all the keys from map. Okay? How do we get it? Let's say phone book dot, there is a method called key set. Look at it, key set, and it is returning set of, look at it. When I mouse over it, it tells me what is the return type. Return type is set of string. The return type is set of string. So set of string, all the keys it gave me, and then here import java.util.set. Look at it. So when you ask your phone book, can you give me all the keys? Can you give me all the keys? And you got set of strings, meaning all the keys you got it. These are the keys. Anup, Lena, Venkat, Ravi, all of these, just the left-hand side keys, it gave you in the form of set. Why did it give set? Can one of you tell me why it gave you set, not list here? No duplicates, precisely. Thanks, Uma. So what did you understand from that? What did you understand? Map does not accept duplicate keys. We understand that, right? That is why it will make sure that all the keys are unique here, okay? And then it's giving you all those unique keys in the form of set of strings. Now you iterate through all of them. Iterate through all of them. Now you print out key equal to, now you get all the key. You can print all the keys here. Look at it, what you get. See, you got the key as Lena, Anup, Ravi, Venkat. So you got these 4 keys. But of course it doesn't maintain the order. It does not maintain the order anyway, because it's a hash based, and it is a simple hash map. Okay, there is a different version of map called linked hash map that actually maintains the order also. There is a different version of it because it maintains all the keys in the linked list under the hood. So that specific implementation is called linked hash map. But let's not worry about linked hash map for now. The hash map is, that's the functionality. So if you want to get all the keys, you can get it dot key set. Okay. Now you got the key. Now I want to get all the values for everybody, right? This is key. Let's get the value. Value is, okay. Now tell me, once I get the key, how can I get the value? How can I get the value once I get the key? I can use phone book dot. I can use map dot get method, right? We just used here, right? See here now, phone book dot get, and I will pass whatever the key that I got it here. I'm passing it. That's it. So dynamically, your Leena will be passed here, your Anup will be passed here, your Ravi will be passed here, your Venkat will be passed here, and it will get the value and it will print it here. Make sense? I hope there is no confusion there. We can talk. See here, Leena, her phone number, Anup, her phone number, Ravi, her phone number, Venkat, her phone number. So first get all the keys, and from the keys get the value. Simple. Agree? And there is a one more also. I hope you'll not get confused with this one. As I told you, in map, every key value pair is an entry. Every key value pair is an entry. You can directly ask for entry. Okay? This map has a method called this get all the entries. You know, there is a scenario 3. In scenario 2, what did we do? We got all the keys from the map. Now, let's get all the entries itself. Each entry will have a key and value, key and value, key and value, like that. Get all the entries from map. Now, your map dot, there is a method called entry set. Entry set. Now, entry set, what it returns is, it returns set of, okay, set of entry objects. There is an entry objects entry. So in the java.util.map, this entry is defined as a private interface, okay, as a private class. So entry, and then again, what kind of entries are we getting? Key is string and value is string, right? Okay, let's define them. Key is string and then value is also string. Now, this is how we get all the entries from the phone book. Not only from the phone book, but from any map, you get all the entries. I'll tell you what exactly is happening. You are getting set of these objects. What are these objects? Entry. Like how you define your set of string, you got the set of students. Similarly, you got set of entries, but that entry is a generic class, meaning when you define your entry, you have to tell what is your key and what is your value. Your key is string here and your value is also string. Now we get all the entries. This entries is nothing but your set. Now when you have a set, you can definitely iterate through the set, right? Now let's look at each entry. This is entry, right? Now let's look at each entry. Inside entries, this is like your enhanced for loop for student, colon students. It's exactly like that. Okay. Now you say, let's print the key and value. So you don't have to go to map to get it. It's giving you key and value. It is putting together as an object and giving you that object. Key equal to, entry dot get key. See this one? It has two methods called get key and get value. So that entry object has two methods called get key and get value. And you'll get it. That's it. See here? You get the key, you get the value. You get the key, you get the value. Exact same situation, but you're doing it little differently. Here, you are getting all the keys first, and then you're going to the map again. Can you give me the value of this key? I know the key, can you give me it? But here you're getting, hey, can you give me all the entries? I'm not asking for the keys. I'm asking for the every line there. Key and value combination together is an object called entry. Okay, and this entry is inside map interface. So inside map, they declare this one as a private interface. Okay. Make sense? I have one question regarding the hash. Oh no, it's long back. Okay, now we got it. Any questions? Let me stop here for a couple of minutes and then let's talk about it, because it's been, I'm talking, you're being quiet. So let's step back here for a second and then I'll take different examples. I'll take one more example. Does it make sense, first of all? Can one of you tell me whether you are following?
Yeah.
Yeah?
Yeah, yes, Venkat.
Does it make sense? Is it Greek and Latin? Okay. Yuri is asking a fantastic question here. Can key have multiple values? Yuri, that's a great question. Okay. Can key have multiple, so me, I know so many languages. What do you mean? I didn't understand. Oh, yeah. Okay, got it. So, okay, Yuri is asking a question, can a key have more than one values? Absolutely. You can, but the way you have to do it is, because you cannot have the duplicate keys here. You cannot have the duplicate keys. So what you have to do in that case, I know it's a little complicated example, but I'll show you. I think you'll go mad with this example. Let's say, we are maintaining several phone books. Is that fair? Now let's maintain all the students based on their city. Okay, let's look at it. What I'm saying here is that map of, okay, your key is going to be string, okay, but your value is going to be list of string. Okay, now let's say phone book equal to new hash map, and your key is going to be string, and your value is going to be list of strings. So this is how you do it. This is how you do it. Now, because directly it does not accept the duplicate values. So what you have to do is, first you get, when you try to add a value to this phone book, right? Then at that time, what you do is, if phone book, or let me do it this way, phone book dot get, okay, and then you give the key. Let's say Yuri. Now, what do you get back? You'll get the list of string back. All the Yuri's phone numbers, right? Yuri's phone numbers. Okay, these are your phone numbers. But first time you may have null, right? Because first time maybe there is no entry at all with Yuri. So what you do is, if Yuri's phone numbers is null, it's a little complicated example. So then what you do is, you create a brand new array list or linked list, whatever that one is. Okay? And now you add this guy's entry now. Now you are adding the first phone number. Let's say 1, 2, 3, 4. So you added the first phone number. If the phone numbers is not now, then you already got the list here, right? Now you add the new guy. You add this phone number. Are you getting it? This is how you typically add. And there are some utility modules called there are some utility libraries. One of them is called Google Guava. Google has a Java library called Guava that's very famous. And also there is a Commons collections from Apache. So there are some libraries out there who will do better than this one. You don't have to write this much code. There is a concept called multi-map. You can use that one to achieve your goal. But this is how it works using plain simple Java. Agree? Did you get it? I mean, I know it's complicated. If you didn't get it, don't worry. You will get it because we are talking about very basics of collections, and this is decent code. So, okay. Since you asked, I just showed it to you. Okay. Now, this is about hash map. As I told you, linked hash map, there is something called linked hash map. Linked hash map, yeah. So there is another implementation of hash map called, there is another implementation of map called linked hash map. So linked hash map demo. I'll copy the same code. Okay. The only difference is that the only difference is going to be instead of hash map, you're saying linked hash map. The only difference you will see here is that the only difference that you will see in this case is that it will maintain the order. So when you ask for, see here, it's, what is this one? I changed from hash map to linked hash map, right? Your Eclipse is giving a warning. The import java.util.hashmap is never used. So you don't need to import this guy because we changed from hash map to linked hash map. Okay? There is a generally shortcut, Eclipse shortcut. This is not an error, by the way. This is just a warning. It's telling you that, hey, write better code. Right click, source, organize imports. See this one? Organize imports. It will automatically delete unused imports. And there is a shortcut, Control-Shift-O, if you want to do that. Anyways, that's not my point. If you use a linked hash map, it will maintain the order of the keys. So when you get it here in the scenario 1, not in the scenario 1, in the scenario 2, you're asking for all the keys, right? Then you will get exactly in this order, Anup, Leena, Venkat, Ravi. Exactly you will get that one. If you want to take a look at it, take a look at it. So you will get it exactly like this, Anup, Leena, Venkat, Ravi. Anup, Leena, Venkat, Ravi. So it maintains the order because under the hood it actually maintain it will maintain a linked list to maintain all the keys separately. So okay, so to maintain the keys it will maintain linked list under the hood. So linked hash map is like a hash map for storing the keys and values, and it will also hold all the keys in the linked list. That's about linked hash map. And there is another map implementation called tree map, like exactly how you have your tree set, your tree map is exactly same. Your tree map is exactly same. Oops. Your tree map is exactly same. I can use exact same code. Tree map. Okay. So if you use this one, what happens is all these keys, right? Anup, Leena, Venkat, Ravi. Let's add in this order. Let's add Venkat, Ravi, Leena, and Anup. What tree map does is it does exactly like a tree set. Okay, it will sort all of these entries based on their keys. So what are the keys here? Venkat, VRAL, right? So what is the lexical order? Because these are all strings, and again, string implements comparable interface and compare to method. So it provides this order, right? A, L, or V. So we'll see Anup entry first, and then Leena entry next, and then Ravi entry next, and then Venkat. If you want to look at it, go ahead and look at it. So tree map maintains the order. Anup, Leena, Ravi, Venkat. Even though we did not, even though we put it in a different order. If you want to use the exact same order as you are adding to the map, then go for linked hash map. If you want all the keys to be sorted, then go for tree map. Again, if you provide, we didn't look at it. If you want to, in this case it is a string, right? But what happens if you want to put all the student objects? In that case, your student object has to implement comparable interface and provide the implementation for compare to method. Make sense? In the linked hash map, I don't need to complicate this one. I'll just show you that. Get all the keys. All these keys are maintaining the order. That's all I wanted to show. Now let's look at, we looked at tree map. What else do we want to look at? I will show you how you use maps if the value is not a string, right? If the value is not a string, it's very simple. I'll use hash map. I'll use hash map. So I'll take these 4 students. Okay, and now what I'm doing is I'm maintaining their phone book, but this time what I'm doing is I will maintain their key as their student ID. Okay, I think student ID makes sense, and then as the value I can maintain their names, right? But I don't want to maintain their names. I want to maintain their entire information. Their key is the student ID, and I want to put the entire student object there in the bag, in the map, I mean. You got it, right? So this is what I want to do. Map. So my key is going to be integer. By the way, you cannot use your primitives in your collections as the keys here, or even the values, because they have to be objects. You have your int, long, boolean, etc. These are all primitives, right? Okay. When you're using them in collections, you have to use their object counterparts. They are called boxed objects. You have int as a primitive, but you have an object called integer. You have long, but you have an object called long. You have double as a primitive. You have an object called double. D uppercase, L uppercase, I uppercase. These are the actual objects. These primitives have been provided by Java to you only for the convenience. Okay? And these are the real objects. And these real objects have the real methods, like integer dot %. You provide a string and it will give you the int. Make sense? So when you're using them, you have to use the actual objects, like a map of integer. And what is the value here? Can one of you tell me? I'm getting bored here, me speaking alone. So can one of you help me? So I want to keep their ID as the key. I want to keep their ID as the key, and then the whole student object as the value. So I'll keep student here.
Student.
Right. Somebody asked, Rohit asked a question. We'll talk about it. I'll answer that question later, okay? Don't want to get deviated for now. So let's say students equal to new hash map. Okay. That's it. Now students dot add, students dot put. I was thinking of all the other collections. Okay. Students dot put. What is the key here? The key is let's say 5 and then student 1, right? Right? For student 1 object, for Aruna entry, 5 is the key. 5 is her ID, right? And then I added Aruna, and now I'm going to add Yuri now, and his ID is 1. Okay? Make sense? 3, 4, 5. Okay. Now, sorry. Now student 3 and then student 4. Now student 3 is you, Jyoti, and then I'll put her ID is 4, and then Kal's ID is 3. Make sense? Now this is how you will use your map. See, it's not string here. Your keys are integers. Your values are the real objects, the ones you created. So now you can use you can get all the keys. You can say students, or you can get students.get. Okay, I want to get an entry or object that is associated with ID 4. Okay, so whose record do I get? I'll get, whose record do I get? I get Jyoti's record, right? Then I'll print to see what is that particular student's name. Student 4 name is s dot get name. Got it? Jyoti. And you can print all the other information. So what is the use here? I don't want to store their IDs and their names. I want to store their IDs and the whole objects, or I want to store their social security number with the whole student, and then I'll maintain that here. If you want to get a particular student information, then give me your social security number. You just say map.get. You pass me the social security number because that is a key. I'll give you the whole student object and you do whatever you want to do it. I'm not only giving you their name, I'm giving you their ID, name, city, state, zip code, and that object can grow. Agree? And we use it very, 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 very often. It is not predominant for us to use non-string objects as keys. Very rarely we see non-string objects being used, or non-integer non-string objects being used as keys here. But it's very often we see the objects are used as values. Okay. Make sense? Yuri, you have a question?
No, I don't have. Except for in the last one, can you print the whole record, like the whole students, like the whole object?
Good question. So you're asking, can you print rather than name, can you print everything? Is that what you're asking?
Yes, yes.
Okay. Yes, you can. So what do you have to do? S dot get name, and then you will get S dot get city, S dot get state, etc. You have to get it and print it, right? But there is a method. There is a method called toString. There is a method in java.lang.object. This is also one of the methods that every object inherits. Every object inherits this method, like how you have equals and hash code. Similarly, you have a method called toString. There is a method in our java.lang.object called toString, meaning, hey, can you provide the string representation of the objects? String representation of the object that you are representing. So by default, it provides some junk built based on memory address, etc. of the object. But if you want to give meaningful information, when you print student, when you print the whole object, you want student's name, ID, and city, state, zip code to be printed properly, right? So what you do is you go ahead and override a method called toString here. Okay, you override toString here, and here what you'll do is you will just provide that information. This dot, or you can just say ID. You can just say ID equal to ID, and then name equal to name, or you can say this dot name. Okay, and then something like this. Okay, city equal to, I think you got the point. So I'm just constructing a string and giving it back. So now all I have to do here is that in my hash map, instead of calling s.getName, I'll just say just s. Behind the scenes, it will call the toString method, or you can explicitly call the toString also, but you don't need to. You just say, can you just print me the object s? Then behind the scenes, it will call your toString method, and then it will print exactly like this. See, it will print ID equal to 4, student 4, or you just say S if you don't want this one. See, ID equal to 4, name equal to Jyoti, city equal to Rochester. Get it?
Thank you. Yes, thank you.
No problem. There is a method. This is like how you have your hash code and equals. Your toString is also a method that every object inherits from java.lang.object. And actually, we generally, this is okay for this one, but if you have if you want to combine 50 strings, then we typically don't use it this way. We use something called a string buffer, and there is string builder. There is a better version called string builder, and we'll talk about that later. Actually, we'll use them, we'll append them. What is why is a string immutable object? What is a string buffer mutable? There is a topic. There is a separate topic on that. I know I didn't talk about it. In fact, in a lot of classes, a lot of batches, I typically talk before collections, but I did not talk about it this time. That's a different topic. So this is how we use in the maps. We use the objects. That's it. And what I wanted to do is, we have no class, as you mentioned, string is preferred type to be used as key. Why is that so? Actually, Rohit, let's talk. There is no way I wanted to say that string is preferred. Absolutely no. That statement is not correct. What I meant to say there is, it is very, we often use strings as the keys. It's not preferred or anything. There is no preference. If you need to use these objects as the keys, absolutely, map supports it. It does not matter whether it is a string or very complicated object. All I need is, because we talked about the underlying data structure of hash map today. It's a array. And it actually calls your hash code of that particular key, okay? If this is integer, it will call the hash code of that. If it is string, it will call the hash code to find out where it has to insert in that particular array. So it doesn't matter whether it is a string or any object. Your hash map simply calls the hash set to find out where to insert. It's actually backed by, array data structure. But it's not in a sequential fashion, like exactly how hash set works. It is based on the hash set. But if there is already an entry in that particular location, then it will use equals to see if it is really equal, because your map does not take duplicate entries, right? Duplicate keys. So then it will check, hey, is this same as this key? Is this same as this key? If it is not, everyone will be sitting there in that particular index. Okay.
Yeah.
I think you joined late, right?
Yeah, I just
Okay.
joined at
Okay.
half-
We talked about it. Go watch this. It's a very similar concept to your hash set.
Okay,
Okay.
sure.
So it doesn't matter whether it is sorry.
Okay, sorry, go ahead. Yeah.
No, it doesn't matter whether it is a string, but my point is, typically in the real world, I've been seeing it for probably 15 years, right? So in the keys, typically we use strings or integer, simple data structures. That is what I meant. But the values, definitely the big objects will come into picture. But the keys I've very rarely seen. I myself had to do very rarely. So here it will always have a student or integer. Sorry, strings or integers, longs, etc.
Okay. There was one more question asked, like, what is, you told there is a small small int and a capital int, like the integer, like a primitive and the object. What is the difference? Because I'm not sure which has to be used at what context. I don't know really. Today also I'm getting confused about that.
Sure. So we have these primitives, right?
Yeah.
Let me talk about it. So we have these primitives: int, long, char, boolean, etc. Right? So these are,
If you don't mind, can you define just what the primitive is?
yeah. Just give me a minute. So all these primitives, they contain only the state. Okay, they just hold a value. That's all. There is no behavior. No behavior. Objects contain both state and behavior, right? So these primitives do not contain behavior. They just hold a value of something. If I say int Rohit's age or something like this, 25, okay? So this variable is of type int holding a value 25. That's all. Okay? It just holds the state of it. There is no behavior, meaning in a typical object, it will contain both state and behavior, and you can get several representations of it, right? And you can apply several transformations to it, meaning you can call different methods on it, right? Here, there is no method. It just holds the state. Now, but the Java is an object-oriented programming language. Other than these 7-8 primitives, everything is an object. Whether Java provides it or you write it, everything is an object, right? Okay, and every object will have both state and behavior. You will have a lot of methods, you can call it. You can define the functionality. Hey, can you do, if I say 25.763, okay, if I stored this as an object here, hey, can you give me the first part of it? You know, number before decimal. Can you give me the number after decimal? Can you give me the third one? Can you give me the fourth? So you can write a lot of methods to it, right? But this is an object. This is not an object. This just holds a value. That's it, right? So what Java did is, for all these primitives, they provided corresponding boxed objects or wrapper objects. They call boxed objects are called wrapper objects, meaning if you really needed an object, okay, especially in the case of collections here, right? In the case of collections, when you say set of something, you must pass an object, meaning the way they defined is, for all the objects, there is a DAD, right? Java.lang object, right? Right?
Yeah.
So all of these data structures, when you define, right? When you define your data structures, you say that set of object, right? Meaning,
Right.
hey, you can pass me any object.
Okay.
Okay? You can pass me any object. Unfortunately, you can't pass any of this.
Exactly.
You can't pass any of this because this is not an object. What you are saying is, hey, pass me an object or any of the descendants of the object. Meaning any of the subtype of java.lang object, right?
Right.
So what Java provided for us is, it also provided the object representations for all of these primitives, buddy. So it provided the object representations for all of these objects. So int, the object representation is integer. So in fact, it is in a package called java.lang. So they created a class called java.lang.integer. For long, they created an object called long. For char, they created an object called character. And then Boolean, they created an object called Boolean. Now, let's take a look at it. I'll show you a JDK 7 API. Let's look at it, all of us together, and then I'll show you. Okay, so here, so java.lang has a class called integer here. See here? Now, this is a first class object, like how you and I define our objects. This is a, right, Java is an object-oriented programming language, and objects are the first class citizens there, right?
Right.
So this is a first class citizen in the object world. In our object world of Java, integer is a first class citizen, meaning it has both fields, your instance variables. See this one? You can define max value. You can define a min value. So anybody can get it. Anybody can ask for it. Integer.min value. Can you give me the minimum value that I can define? But how can you get it from int? You can never get any of those values here. This is just a placeholder. It's just a holder that holds a value. Getting it?
Yeah.
Now you have the constructor. See, you have the constructors. You provide any integer value, you can create this object. You can provide any string object, any string representation of an integer. You can create an integer like that. So meaning new integer 23 like this. So you are providing in the form of string, right?
Yeah.
Now,
Yeah.
now look at this one. The beauty is here. The beauty is here, the actual object. Now, can you give me the bit count? Can you give me the byte value? Can you compare with another int and tell me what happens? Can you please decode for me? Can you give me the double value of it? Can you tell me if these are equals? Can you give me the float value? Can you give me the get integer? Can you give me the hash code? Can you give me the int value of it? Can you give me the number of leading zeros? Can you give me the number of trailing zeros? Hey, I'll give you the string format, string representation of number. Can you please parse it for me and give you an int here? Can you please reverse for me? Can you please reverse bytes? Can you rotate left? Can you do a short value? Can you give me the short value? Can you do a sign num? So you can do all of this. This is the power of object, right? You can't do any of it with your plain simple vanilla primitive. You can hold it. You can definitely hold a value and you can pass it around. You can do a plus, minus, all of that. You can do a mathematical operation, all of that. But you cannot do any of it. They created a wrapper object. If you have to design your object like this, right? They just created a wrapper object here, okay? Let's say my int. Okay, so it just holds a value here, buddy. Under the hood, it's actually int. Okay, but now I can provide array of methods which will transform this value. Can you give me the left side? Can you give me the right side value? Can you give me the last two digits? Can you give me the trailing zeros? Can you tell me the value of this? You can write any number based on this value. You agree?
Yeah. Yeah.
That's the power of objects. And in fact, in JDK 5, I'm going to give that as a homework. In JDK 5, they actually made our life easy to transform from the primitives to this one. They do it auto boxing and unboxing. It's a very popular interview question, by the way.
Exactly.
Okay. So we'll talk about that when we talk about it, but that's what the story is about. Mm-hmm. Now, I wanted to spend a few minutes here, talk about the homework. Okay? What I wanted to talk... Go ahead, Rohit.
Sorry for interruption.
No problem at all.
Now,
no.
The point is now that gives me now a new question saying that,
absolutely.
When we define a string, say for string S is equal to Rohit, I say it as a capital S, right? What if I write with a small s, string is a small s is equal to Rohit? Will it give me an error then?
Let's talk about it. Very interesting. Let's look at it.
I remember long back I did as like small string name, but it gave me an error. I think so, but I'm not sure still. I just want to click on that.
Definitely. You're asking like this, right?
Yeah, exactly.
Let me tell you one thing. I think let me repeat this for everybody. We have these primitives in Java, entire programming language. In the entire Java stack, we have int, long, boolean, char, short, etc. Right?
But
okay.
String is not,
wait. Oh, sorry. Go ahead. I'm coming there.
Actually, it's not a primitive data type.
Exactly. String is not one of them. String is not one of them. And your string is in a package called java.lang. And string is a first-class citizen in the entire Java object world. It is an object. And java.lang.string, all these we are talking about it. Java.lang. is a package. This is where there is an object called string, and this extends obviously java.lang object. This is a first class citizen. This is an object, okay? And in fact, this implements, I just told you that it implements comparable interfaces, a comparable interface under the hood. I just told you, right?
Yeah.
There is no such thing called small letter S string. There is no such thing. So you're assuming I think it's very, there's nothing wrong in it. Okay, it's right thinking. You're thinking that, hey, we have these many primitives. Maybe they defined, maybe they gave string also as as a primitive. Definitely, it's a good thinking. Nothing wrong with it. But Java has not given this. There is no primitive string. There is only one string. That string is an object.
Okay.
Very, very clear. Look at it.
Yeah, that's cool.
So we are talking about this one. Every single time I write a string, name equal to Rohit, a string, name equal to Jyoti's, whatever that one is, I'm talking about the object string. And there is only one string. I wanted to repeat it. There is no primitive string in Java. There is only an object. See here? What happens when you say string str equal to ABC? Under the hood, it creates an object and your str is pointing to that object as if you created new. So the only thing, what you are not doing here is though, you are not doing this one. String str equal to new string of Rohit. You are not doing it. So if you always do it, you wouldn't have gotten this question, Rohit, right? Because you're doing new. You are doing new string is I'm calling the constructor of string. I'm passing this string of characters, right?
Right.
They cheat. They're kind of it's not cheating, but it's they wanted to help us. Rather than writing this much, what compiler does is, hey, you know what? For your convenience, you don't have to do this one for strings. You just provide your string of characters here. Under the hood, I will create an object for you. I will write this guy for you. You don't have to do it first. So they just provided this as a convenience. Agree?
Yeah.
But what exactly is happening under the hood is actually this one. Make sense? So you're actually calling the strings constructor. So there is no primitive string.
Okay.
Fantastic.
Cool. Thanks.
No problem at any time. Now let's come to homework. First, let's talk about next class, right? We don't have class tomorrow. Definitely. No class on Thursday, Friday, Saturday, Sunday, Monday as well. Okay. I'll see everybody on Tuesday. That's March 31st. So we don't have class for 5 days. In fact, that is why I took 2 classes, 2 consecutive classes, yesterday and today. So there is, we'll meet again on Tuesday at 6:30. But as I told you, certain topics I will give as a homework. Okay, I'll do it in every batch because this batch I spent decent time on collections. Actually, I went above and beyond to talk about under the hood stuff like a linker list, error list, what exactly happens, equals hash code, too deep. Okay, so what I need from you is I want you to watch 2 videos for me. One of them is they're in the previous batch. Go to videos in the previous batch. I will actually put them. I'll immediately copy and put it in February, Feb 2015 also. But go to previous batch. I want you to watch this one, session 11, exception handling. This is error handling. And also I want you to do this one for me, new language features. JDK5 has provided new language features. Here I talk about enhanced for loop. I talked about enhanced for loop, which we already talked about it. But I talk about generics. I talk about enums. I'll talk about reflection. Very, very, very important concept. Okay. So I want, in addition to completely grinding the collections, I wanted to say this batch go only the Feb 2015 videos, because I believe at least that this is the best. So but these two I want you to finish by the time I come back. Okay, and then I'll spend the entire Tuesday. Once I come back, I will not talk about any new concepts. You come with questions. Let's just spend time, the whole entire 2 hours. I wanted to chat with you guys. You bring all the way from the first class to now, all the way from what is Java to here. I want to talk about everything. Come, any question. Okay, and I'll take time and I'll explain. I want to make sure one more time on 31st that not just few people on the same page, but every one of you. My goal is to bring every one of you on the same page, and then before we move on to something else. Okay, so is that fair? Definitely. I will do it on the Tuesday itself. We'll do, we'll combine collections. If it takes 2 classes, I don't mind, Rohit. If it takes 1 week, I don't mind. So time is never a priority for me. Okay, so don't even worry about it. I will never leave.
Yeah, because you know how important the collections are. So I want that.
Yep.
Because I personally felt that this went a little bit like kind of fast. I mean, just frankly letting you know. I mean, I felt that this went a little bit up and down here and there, above and beyond, because I know this has to be a little bit structured way. I felt that. So I think that probably 1 or 2 sessions more doubts clarification specifically on collections is really needed.
Absolutely.
Because being an important topic, I know it's really important collections part. So I recommend having 1 or 2 sessions, maybe for doubt clarification, and you just dig into like maybe by explaining more, but the doubts will come out from that.
You watch the videos one more time. I recommend, that is what I recommend previously also. If any doubts, absolutely. I want to spend 1 class, no, 2 class, absolutely.
Sure, thanks.
Okay, no problem. Can we see a very, very complicated sample of collections framework for analysis? Venkat Krishna.
Yes, Venkat. Yeah.
I can't at this point. You heard Rohit's comment, right? So
Correct.
First let's be on the same page, and then we'll come back and we can definitely, actually we did a small this one also, the movie store building. Here actually I believe we have used it to an extent. If you really want to go above that, then it has to be a separate one, maybe just for the kicks. A couple of you, if you want to come, just chat with me, and then I'll show you a very complicated example. Okay?
Okay.
So one point is that, yeah, I have to feed enough information, but also it shouldn't be super fast, right?
But it's actually these 5 days also we need to go over what you have taught us and
Actually,
completely digest all the collections and the different types of collections, and I think these 5 days would be really.
You know what? If we think that, if we all think that, you know what, this is too much, then let's cancel it. We'll worry about it later, right? So let's take the collections into bloodstream. Okay? If
Yeah.
that's what, you guys want to do it, absolutely. I have no issues actually.
That sounds good. That sounds good.
Okay. So, but this is what I would recommend, right? Today is what? Tuesday? Today is Wednesday, huh? Okay. So, Thursday, tomorrow, please meet at 6:30. And then Friday also, I would recommend 6:30. Please meet. And then just pound it. The whole collections. You do as many examples as possible. Okay. And in fact, to an extent, I have here in my homework, Java Venkat, go to homework code Java collections. Look at this one, and then you do it. Okay. So Thursday, Friday, and then I'm assuming, hey, will you be able to meet on Friday? So who is doing it these 5 days? Uma, you'll be able to do it for all 5 days? Or wonderful. You're always there. So Saturday at 9 or 10?
10 o'clock.
10 o'clock, okay. 10 to 12, okay. And then Sunday 10 to 12. Okay. And then Monday as well. Please meet on Monday also, because I'll be coming on Monday pretty late night. So I want to make sure, take advantage of this one. Take advantage of these 5 days. 5 days. Any basic questions or any complicated questions, everything you just pound it. Okay? And then we'll have fun. So time is never a problem. We can definitely step back. Maybe I did, I paced myself a little bit. So assuming that, but I gave too much information probably. That's also one of the factors. Definitely I'll take it as a feedback. But let's do it. Right?
Venkat?
Yeah.
Just one question. I'm still lagging in this concept. So I have one question in the interfaces.
Absolutely. Let's talk.
Okay. So when I created an interface, and is it mandatory that when the interface variable the interface variable, should it be initialized at the time of declaration itself? Because if I'm not doing it, it is throwing an error.
Say that again.
So when I am initializing the interface variable, should I initialize the interface variable at the time of declaration itself?
Any takers for her question? Any volunteers? Anybody wants to answer that question?
I can answer.
Please.
Venkat.
Yeah, absolutely.
Yeah, interfaces can have variables also. I mean, fields we can define, but they should be final, whenever we declare them, they should be static and final.
Yeah, so interface variables should be public, static, and final, correct? So
Right.
it should be declared at the time of, at the time of declaration itself.
No, I think
Yeah, they should be initialized. Yeah.
Correct. Yep.
Shall I tell you why?
I-
Sorry, go ahead.
And one more thing that I want to clarify.
No. Before one more thing, let's talk about it. I want to add my.
have any, they can't have any methods or anything, right? They just have public void eat or public void move. That's all they can have, right?
That is a method signature. Yes,
That
they
is
will
method.
only
I'm
have
talking about the variables.
exactly.
Variables, okay.
So in the case of classes, okay. So let's talk about it. Let's say movable. Okay, every object that is movable, okay, has should implement a method called move or whatever, walk, run, etc. Right? So now in the classes you have something called fields or instance variables. Those instance variables get initialized automatically when a new instance is created. But can you ever create an instance on mobile? Can you ever instantiate an abstract class? Can you ever instantiate an interface? Can you ever instantiate an abstract class? Can you ever instantiate an interface? Can you? Movable, M equal to new movable, can you ever do that?
No.
Absolutely no.
We
This
can
is
just
only a public interface. This is actually only public interface. Public facing to call the methods. Or you can declare variables, they are like a constants. One, they're always public, all the methods are public, all the variables are public. Okay, and then the variables. So the variables also, you have to initialize them. Because it does not get, nobody can initialize it, right? Because in the case of classes, the fields or instance variables get initialized when an instance gets created. But here, you can never instantiate it, Jyoti.
Yes, since it will be 100% abstract class, correct? The interfaces.
Absolutely.
So we cannot instantiate.
Absolutely.
And we cannot even the constructor concept also. I don't think it's applicable
There
here.
is no constructor because what do you mean by constructor here? Tell me. See here, movable M equal to new movable. This is constructor, right, Jyoti?
Yeah, correct.
This
So and
is
also you cannot initialize the instance variables.
Exactly.
So
There is
that's
no
why the constructor concept cannot be applicable to
You got it.
interface.
Precisely. See here?
Yeah.
This is when. So you can't even create this. So there is no concept of constructor here. So there are no concept of constructors. And then there are no uninitialized variables because of the fact that it can never be instantiated. It's exactly like your abstract class. It's even actually worse than abstract class. This is 100% abstract, right? Pure abstract. Okay, what's the second point that you are making?
No, I'm done.
Oh, you're done? Okay. Rohit, did you get that? Wonderful. Anybody has any questions? Rohit, do you have any questions? Okay. So these are the topics that you want to go back home and then watch these videos at least a couple of times. I'm just checking in the code right now, but I totally understand some or all of you, if you don't get everything into your bloodstream, right here, and it is possible because these are really, really, really core concepts. Okay, but very, very important too, and very popular in interviews too. So go ahead and watch them at least once, but once may not be sufficient. And understand now from here onwards, once we talk about exception handling, we are all going to combine. Now, we actually sort of looked at the examples in isolation so far until this point. Now, we will combine. I'll take back. See, all the interface concepts, right? We put together in action for collections. Now, once we learn about exception handling, we will combine interfaces, inheritance, collections, and exception handling. So going forward, we will only collect all the examples and make a bigger examples. So if you do not understand any concepts that we talked about so far, it is time to catch up. Everybody.
Okay.
Make sense? Excellent. So, good night. Go ahead.
So to get the code, it's use the repositories, right? That's the only way to get the code.
Absolutely, sir. Absolutely.
Okay. Yeah.
Okay. So please, all of you work a lot. Meet here as a team, and then people who are in a position to help, please help others. Okay. I think that's it. See you all on Tuesday. Have a good night.